As we're looking at the 5 isomer types, we are now going to focus on the positional isomers. Let's continue looking at our isomers. We're going to look at the structural isomer known as a positional isomer. Positional isomers, as their name suggests, are found when there's the same types of attachments and the skeleton is basically the same, but we've changed the position of the functional group. For things like methyl groups and ethyl groups, those are not considered functional groups, so when their position changes, those are skeletal isomers. But when it's something like an OH or a chlorine, or even a double or triple bond, then we can start to see positional isomers. Positional isomers differ in the position of a double bond, a triple bond, a halogen atom, or any other functional group. So we're going to look at some examples of different positional isomers for different classes of compounds. One of the key things to note is that we will always have the same class of compound when we find a positional isomer. The first step in classifying isomerism is to make sure that we could possibly have an isomer, and that just entails checking the formula to make sure that we have the same number of carbons, hydrogens, oxygens, and other substituents. The second step then is to look to see what functional group is present. If we look at the compound and we see that it is a hydrocarbon that doesn't have double bonds or triple bonds in it, then we know that we have an alkane. It is most likely to be a skeletal isomer and nothing else. And as mentioned in the previous video, for this class, if we see an alkane, the only choice will be skeletal isomer. So now, assuming we do have a functional group, we're going to look to see is it a positional isomer or one of the other isomer possibilities. So for this, what we want to do next is not only find the functional group, but classify it. So now if we can classify what the functional group is, it'll tell us the class of compound we're looking at. If they are the same class of compound, then there's a good chance that you have a positional isomer. How do you know if it actually is a positional isomer? It still could be the same. The way that you can tell if it's a positional isomer is that the position of the functional group will move from one position to a different position. As I go through these examples, I'm going to also give you some practice with classifying the compound and then with naming each of the two compounds. So let's look at letter A first, which is C4H8. We're going to have two different versions of C4H8. Step 1, are these possibly isomers? Well, they both have C4H8, so we know that they could possibly be isomers. They could also be the same, but we'll come back to that. So next step is to find the functional group. I'm going to put an arrow at the functional group so you can see it. Put the arrows in, and now we're going to classify the compounds. So the first one has a double bond. The second one has a carbon-carbon double bond. And since they both have carbon-carbon double bonds, they are the same class of compound. Let's go ahead and name that class of compound. Hopefully you got that. That is an alkene. And now let's go ahead and name them. So just as a reminder on naming, the first thing you want to do is find the ending on it. So this is an alkene. The ending will be -ene, and that's for both of them. And then there's 4 carbons in the line, so they're both going to be types of butenes. And then we're just going to change the number. So on the first one, it's on carbon number 1, and on the second one, it's on carbon 2. So the first one is 1-butene, and the second one is 2-butene. Okay, let's look at compound B, which is C4H6. Here we see that we have the same number of carbons and hydrogens, so we definitely know this is a possibility of being an isomer. And we're going to find our functional groups right here and here. And we see that it's a triple bond. What is the class of compound if there's a triple bond present? Hopefully you chose alkyne. And we see that they are both alkynes. We're going to go ahead and try to name them. They both end with Y-N-E for alkyne. They both have 4 carbons in the main chain, and so they're both butynes. The first one, the triple bond, is on number 1, so it's a 1-butyne. And on the second one, the triple bond is on carbon number 2, and that is 2-butyne. And so we can see that the position is the only thing that's really changed. Same functional group, different position. Alrighty, let's try letter C. We have C4H9Cl. two different versions of it. And for this one, we see that we have our functional group is this chlorine here. And we know that these have a possibility of being isomers because they have the same formula. We see that they are on the same class of compound, and I'm going to ask you what that class of compound is. Hopefully you chose haloalkane because we have the right formula for having a halogenated compound that is an alkane. So we know that they could possibly be positional isomers. We need to check it with the name. We see that they are both butanes, and they both have chloro groups, so they're both chlorobutanes. Now let's see what position it is. So on the first one, it's on number 2. Make sure you count this backwards with the lowest number you can for the chlorine. And on the second one, it's on number 1. So we have a 2-chlorobutane and a 1-chlorobutane. Those two are positional isomers. Let's look at letter D. They have the formula C4H10O. So there's a possibility that they are isomers because they have the same formula. Next, we find the functional group here and here, and we see that they are OH, so they're both what class of compound? Hopefully you have that they are alcohols, and then we're going to name them, and for the naming, we're going to end alcohol with OL, then we put AN in front of that, and then we're going to put in the number of carbons, and we see that there are 4, so it's butanol. So they are both butanols, and the first one is going to be on carbon number 2, and the second one is on carbon number 1. So we have 2 butanol and 1 butanol, and we do have 2 positional isomers then. Let's try letter E, which is C4H10O. And since they both have the same formula, there's a possibility that they are isomers. Remember, they could still be the same, but we're going to check for isomer. Now let's see what class of compound we have. And we see here that we have a carbon-oxygen-carbon and another carbon-oxygen-carbon on the other position. So they're both the same, but what class of compound are they? Hopefully you got that these are both ethers. Let's go ahead and name them. So remember, with ethers, we find the main chain first, and we put its name last. So for the first one, we see 3 carbons in the main chain, so this is some sort of propane. And in the second one, it only has 2 carbons in the main chain, and so we're going to call that an ethane. And for the ethers, the oxygen's in the middle of the carbon chain, so we're going to name it with the oxy in the middle of the name. And then we're going to put the chain length of the attached group. So on the first one, we're going to see there's a 1 carbon chain, so we're going to call that meth. And on the second one, we're going to see there's a 2 carbon chain, so it will be eth. And so we have a methoxypropane and an ethoxyethane. And the last step is to put on which number it is on. So let's look at the first one. What number is the oxygen attached to the main chain? 1, 2, or 3? And you should see that it is on carbon number 1. Again, even though it looks like we might be counting the other way, we want to count to give it the lowest number possible. So this is 1 methoxypropane, and the second one is 1 ethoxyethane. In that case, we are not required to put the 1 in, so it is just ethoxyethane. We don't have to put that 1 in because it is only one choice. It could only be on carbon number 1. So again, that was just some extra naming practice. You're just supposed to be noticing that the position of the oxy has changed. In this case, they're both on number 1, but what's changed is the chain length. So that is still considered a positional isomer because the position of the attached group has changed. Now let's look at letter F, which has C5H10O. And again, the molecular formula is the same, so it has a possibility of being an isomer. And then we're going to look at it. We're going to see that we have a functional group with the oxygen here, so C double bond O on it. And when we have a C double bond O and then there is a carbon on both sides, what is the class of compound? Hopefully you got ketone. If this is a ketone, and that one's also a ketone, that means they are the same functional group, and we can continue, and we can see that this is a positional isomer if they are in different positions. Let's practice with naming. This functional group is a ketone. The ending for ketones is -one. So for both of them, we'll have ONE. In front of that, we're going to put AN because everything else is single bonded carbons. So ANONE. And in front of that, we're going to put how long the carbon chain is. So the first one has 5 in the chain. The second one also has 5. So these are both pentanones. And on the first one, what number is the ketone on? I see that it's on number 3, so this is 3-pentanone. And on the second one, we see it's on carbon number 2, and we have 2-pentanone. Let's go on to letter G, which has the molecular formula C4H8O2. They both have the same molecular formula, so that means that they could theoretically be isomers. They could be the same, but they are probably isomers. Let's go ahead and check them out. Let's look for our functional group. Here I see 2 oxygens. That functional group has 2 oxygens with a carbon on the oxygen that's in the middle of this chain. And we see the same thing on the second compound. So it has 2 oxygens with a carbon on both sides of that oxygen. And so we're going to see that this class of compound is an ester. And just glancing at it, you should be able to tell that they are different compounds. One has an ethyl group attached to that oxygen, the other one has a methyl. So we know that they are isomers, and they're the same functional group, so that means that these are positional isomers. Now let's do some naming just to get some practice. We know that with esters, the ending is O8. In front of that will be an AN to say that it is all single bonds other than where the functional group is. And so then we're going to see that the first one is an ethanoate because there are 2 carbons in the main chain, and the second one is a propanoate because there are 3 carbons in the main chain. Now we're going to say what's attached to it. In this case, we don't name that oxygen in the middle because that's part of the functional group, the C double bond OO. So we're going to call this one ethyl ethanoate. And for the second one, we're going to see that it is methyl propanoate. Notice that there is a space between those 2 words because we're saying that those are separated by that oxygen. And our last one, letter H, has C4H11N, and we see that they have the same molecular formula, so they have a possibility of being isomers. We check to see if they're the same or different. In this case, our first thing is we want to check what is our functional group. We see our nitrogen here, and we see that it is not in the same position, so we're going to know it's positional. We also want to name it just to get some practice, and we want to classify it. You can see that it has a nitrogen, but it does not have a C double bond O. That means this is an amine. And for the amines, we name them with the word amino at the start of their name, and then we write the name of the main chain. So for the first one, this is a butane, and for the second one, it is also a butane. So these are both aminobutane, but are they the same compound? No, they're not, because the amine group is on different carbon numbers. So the first one will be 1-aminobutane, and the second one will be 2-aminobutane. And those are some examples of positional isomers. The next section we're going to do is going to be about functional isomers, and that'll be on the next video.